Okay, so on our first reaction here, what kind of reaction are we looking at there? That's a single replacement reaction. We have an ionic compound, okay, and it's reacting with an element. In this case, the element is sodium, which is a metal, okay, and it's producing a different ionic compound involving sodium, and copper is ending up by itself. All right, so this is a single replacement reaction, okay. The compounds involved, copper 2 fluoride, okay, and I figured that out because fluorine's a -1. Okay, so this has to be a +2 here, right? Is reacting with sodium, and that is going to produce sodium fluoride, okay, and copper. Do I need a Roman numeral on copper in this situation? I don't. I only need a Roman numeral if it's in a compound and thus has a charge or has given away electrons. Copper's an element there. Elements don't have charges, okay, when they're by themselves, so I don't need a Roman numeral. It's a mistake I see often, people just over-applying that Roman numeral thing. You don't need a Roman numeral when it's by itself, okay? All right, now we got to balance this thing. So it's not a combustion reaction, so our rule is we start with the biggest number. The biggest number is 2, right? There are 2 fluorines over here, so I'm going to need to put a 2 in front of this, okay? When I do that, it gives me 2 sodiums, so I'm going to have to go back over here and put a 2 there, and then I think I'm good, okay? 1 copper, 2 fluorines, 2 fluorines, 2 sodiums, 2 sodiums, yep. Okay, it's now balanced. Okay, is that ringing a bell a little bit? It's going to take a while. That's why I planned for today to just be kind of a review of what we've been doing because you had a week off. All right. How many people have done the second one? All right, let's look at the second one real quick too. All right, so I've got beryllium. Okay, we'll start writing it out in words here. Okay, beryllium, an element, in this case a metal, and it's reacting with another element, phosphorus. Okay, and that is going to produce beryllium phosphide. Ionic compound. All right, so that's what we're looking at for the word equation. What kind of reaction is that? Somebody whispered it and they were right. Say it louder, you were right. Synthesis, yeah. Okay, it's an element reacting with an element, synthesizing a compound. Okay, so this is a synthesis reaction. All right, now I've got to balance this thing. The rule is start with the biggest number. Okay, biggest number is what? Is 4. All right, so there's 4 phosphorus over here, but there's only 2 in the product. So what needs to go in front of beryllium phosphide? Yeah, we got to put a 2 there, okay, because 2 times 2 is 4. Also, 2 times 3 is 6. So what needs to go in front of the beryllium? A 6. Okay, is it balanced now? It is. Okay, I'll give you a few more minutes to get ahead of me again here, guys. Okay, it's going to take a little while to kind of refresh your memory on how that works, and that's okay. Okay, we've got time. All right, so looking at number 3 here, we're starting out, our reactants are just one compound. Okay, so, and it's molecular, so we'll name it as such, carbon tetrachloride. Okay, and then it's going to go to simply carbon and chlorine. All right, what kind of reaction is that? It's a decomposition reaction. Yeah, it's only got one reactant. That's the only kind that starts that way. Okay, we got to balance it. 4 is the biggest number. So I've got 4 chlorines in the reactants, but only 2 in the product. So what needs to go in front of chlorine there? Yeah, 2. Okay, and then looks like it's balanced because 1 carbon, 4 chlorines. 2 times 2 is 4 chlorines. Yep, that's good. That's the only thing we had to add. Okay. Questions on that one? And for number 4, okay, I've got 2 ionic compounds reacting. So those ionic compounds are hydrogen bromide reacting with barium sulfide. Okay, and that is going to produce two different ionic compounds, hydrogen sulfide and barium bromide. So those are that's our word reaction. What kind of reaction is it?
Double replacement.
Double replacement. Two ionic compounds reacting is always a double replacement reaction. Okay, biggest number is 2. All right, and it's on both hydrogen and bromine. Since they're together on this side, that kind of makes it easy. If I put a 2 here, that balances both my hydrogen and my bromine. There's one barium, one sulfur, one sulfur. Looks like that was the only number we needed to add to balance that. Okay, how many people have done number 5? Okay, let's look at number 5. Okay, so on number 5, ionic compound here, this stuff is iron, and we got to figure out what Roman numeral goes there. So oxygen's always a -2, which gives me 6 negative charges. So I've got to get 6 positive charges from the 2 irons. 6 divided by 2 is 3. So iron 3 oxide. Okay, it's reacting with silver. Okay, and that is going to produce a different ionic compound, silver oxide and iron. Okay, so that's what our word reaction should look like. Questions on the word reaction? Okay, what kind of reaction is it?
Single replacement.
Single replacement, yep, because we have an ionic compound reacting with an element, and the element is switching out. Okay, single replacement. Okay, biggest number is 3. Okay, we got 3 oxygens on this side. So we'll try this. We'll put a 3 here. Okay, that balances my oxygens, but gives me how many silver? 6, yeah, 3 times 2 is 6, so I'm going to put a 6 here. All right, now my silver and my oxygen are balanced. I've got 2 iron here, but only 1 here, so what needs to go right here? Right. Now it's balanced. Okay, how many people have done number 6? All right, I'm going to give you a few more minutes on number 6. Remember, it's a combustion reaction. It's got separate balancing rules. All right, we balance alphabetically and the rule of 2. Okay, so keep those in mind. For this one here, don't worry about naming this stuff because obviously we did not go up to 14 for our learned prefixes. You can just call this stuff hexane. Okay, that's actually what it's called. All right, let's look at that number 6 there. Okay, so we got hexane, okay, and it's reacting with oxygen. Okay, and that's going to produce carbon dioxide and water. Okay, as we already spoiled, okay, this is a combustion reaction because it's carbon and hydrogen reacting with oxygen. Okay. All right, to start the balancing, what do I need to put in front of the hexane? A 2. I need the rule of 2 here because 6 is an even number. All right, 2 times 6 is how many? 12. All right, so I'm going to have to put a 12 here in front of the carbon. All right, then I've got to balance my hydrogen next in line alphabetically. 2 times 14 is 28, so 14 times 2 is 28. Now I need to balance my oxygens. In the carbon dioxide, I have 12 times 2 is 24 oxygens, and I have another 14 oxygens in the water, right? Giving me a total of 38 oxygen atoms on the product side, okay? 24 plus 14, right? What times 2 will give me 38? Pretty sure it's 19. Okay, everybody with me there? Okay. We can't forget that the reason we put these plus signs in here is because we're really supposed to add all the numbers up so that we have the same number of everything on both sides of the arrow. Okay, is that ringing a bell a little bit? Okay. Then, let's see how we do with some of the ones that go the other way. All right, so let's say do 9 through 14. All right, so on number 9 here, okay, the best thing to do before we do like any identifying or anything like that is to write out the reaction in formulas. So magnesium, just magnesium, so Mg, is reacting with nitrogen gas. What do I need to remember about nitrogen when it's by itself?
Molecular element.
It's a molecular element. It's special. It comes as a 2. Okay, crucial to remember that, something that's easy to forget. Okay, and that is going to make magnesium nitride. All right, is that going to be an ionic compound? Magnesium and nitrogen? Okay, what do I have to do with it then? Drop and swap it, right? Okay, so -3, magnesium is a +2, so Mg3, N2. Okay, is how that compound's going to look. Is there a lot more to do when I give you the word equation to make you go to formula? There is way more to do. And there's more chances to make a mistake because you have to build the reaction yourself. Okay, it's way easier when the reaction is built for you and all you have to do is write the names. That's way easier. Okay, this involves, not so much that it's harder, but there's more things you have to be mindful of, okay, when you're building the reaction yourself. All right, so now that I've got that, now I can see what type of reaction it is. What type is it? Yeah, it's a synthesis reaction, yep. Okay, and then we've got to balance it. Looks like nitrogen's already good, 2 and 2. What needs to go here? A 3, yeah. There's 3 magnesiums on the other side, so I've got to put a 3 there. Okay, now the reaction is balanced. Okay. All right, let's look at number 10. So we got beryllium oxide. Okay, so beryllium is Be, and it's with oxygen. Is that an ionic compound? It is. Okay, so I've got to drop and swap it. This is a -2, that's a +2, so it's fine the way I wrote it. Okay, and it's breaking down. So it's breaking down into beryllium and oxygen. What do I have to remember about oxygen? Also a molecular element, comes as a 2 when it is by itself. Okay, so now I've got the reaction written out. What type is it? It's a decomposition, right? All right, and I've got to balance it. Right now the biggest number is 2. It's over there on the oxygen, so what needs to go here? Okay, do I need to put a 2 anywhere else?
Yes.
Yeah. Okay, now it's balanced. Right? It's just going to take a little bit of time to get the rust off, okay? And then you guys will be right back at it, no problem. Okay, keep going. Let's say go up to 15, okay? If you got to 14 already, go up to 15. I'll do 2 more in a couple more minutes. All right, so on number 11 here, okay, we have chromium 2 sulfide, so Cr, okay? And it's the 2+ type. And it's with sulfur, which is a -2, so that compound is fine the way it's written, dropped and swapped. Okay, and it's reacting with copper metal, so Cu. All right, and that is going to produce, okay, copper 2 sulfide, so that's going to be Cu with the 2+ charge, with sulfur, which is a -2. Okay, so that's also fine the way it's written. Okay, and chromium. Okay. What kind of reaction is that? It's a single replacement reaction. And do I need to do anything to it? Looks to me like it's already balanced, right? There's no little numbers in it. Everything is a 1. All right. Silver nitrate. Okay, so that's Ag. Okay, and silver is a +1. And it is with nitrate, NO3, which is a -1, so 1 and 1. That's good the way I have it written. It's reacting with potassium fluoride. Okay, so potassium's a +1, fluorine is a -1, so that compound is also fine the way I wrote it. Okay, and that is going to produce silver fluoride that would be AgF. Okay, plus 1, minus 1, so that compound is fine the way I wrote it. And potassium nitrate. Okay, plus 1, nitrate, minus 1. Okay, that compound is also fine the way I wrote it. Okay, what kind of reaction is that? It's a double replacement reaction. Everything is ionic in that equation, right? It's two ionic compounds reacting. The metals are simply switching partners, silver and potassium switched partners. Okay, so that is a double replacement reaction. Does it require me to do any balancing? No, it's already balanced. Okay, questions on that one? Okay, keep on going here, guys. Let's get up to number 15 done. I'm gonna fix something here. Maybe I'm not. There we go. Come on. Not responding, of course. Okay, let's look at least 13 here. So on number 13, we have tricarbon octahydride. So how many carbons is that? Come on. Okay, so C, oh, come on. C3, okay, H8. Okay, tricarbon octahydride, and it's reacting with or burns in the presence of oxygen. Special element? Yeah. All right, so that's what our reactants are going to look like. Okay, and it's going to produce carbon dioxide, CO2, and water, H2O. All right, what kind of reaction is that? It's a combustion reaction. Okay, so we write that down, combustion. Do I need the rule of 2 for this one? No, I have an odd number this time. So 3 carbons, what needs to go here? Okay, 8 hydrogens, what needs to go here?
4.
Okay, 3 times 2 is 6, plus 4 more is 10 oxygens in the products. What times 2 gives me 10?
5.
Right. Okay, so there we go. That's what that should look like. Balance. How many people are done 14? Okay, 14. All right, so nickel 2 phosphide. All right, so the nickel with the 2 plus charge is with phosphorus, which is a -3. So I'll have to drop and swap Ni3P2. Okay, and it is reacting with bromine. What do I need to remember about bromine? It's special, yeah, and it comes as a 2, right? That is going to produce nickel 2 bromide, so Ni, again with the 2 plus charge, with bromine, okay, which is a -1. So when we drop and swap, that's what that's going to look like. Okay, and phosphorus. What do we need to remember about phosphorus? It's even more special than some. It's P4, right? It's not the most special. The most special is sulfur. Okay, so now if I'm looking at this, biggest number is 4. All right, so we'll start with that and see how it goes. I've got 4 phosphorus over there. What times 2 will give me 4? 2, yeah. Okay, so 2 times 2 is 4. Now my phosphorus are balanced. 2 times 3 nickels is? Yeah, 30 cents. 6 nickels. Okay, I'm sorry, guys, that was terrible. Okay, okay, we got 6 nickels here. Okay, 6 times 2 for the bromines is 12. So I need a 6 over here. Okay, and then everything is balanced. Okay, how many people are done 15? Okay, let's just do 15 and then we'll talk about what's gonna kind of go on here this week. Okay, so nitrogen gas. What do I need to remember about nitrogen when it's by itself? It's a 2. Okay, and it's reacting with oxygen gas, also special. Okay, and that is going to produce dinitrogen and 2 trioxide, O3. Okay, what kind of reaction is that? It's a synthesis reaction. Sorry, what kind was 14? Single replacement, yeah. Okay, so ionic compound reacting with an element. This one here is synthesis. All right, biggest number is 3, so let's balance that first. Okay, I got to come back over here. So lowest common multiple of 2 and 3 would be 6. So I'm going to put a 2 there to get 6 oxygens, a 3 there to get 6 oxygens, and then a 2 here will balance my nitrogens, 4 on each side. Okay. All right, is that ringing a bell? Coming back to you a little bit? Okay, so here's what's going to go on this week. Okay, today we reviewed everything because we had a week off. Tomorrow, we're going to start looking at predicting the products of a chemical reaction. It's really not a lot different than what we're doing right now. You just need to know the patterns. Okay, so the 5 reaction types we've gone over, you need to know those patterns, okay, because you're not going to get those on your test. You have to know those patterns, okay, in order to do this. It really isn't much different than what we're doing now. So we'll do that tomorrow, okay, and work on that Wednesday, Thursday, okay, of this week. Friday you will have a quiz. That quiz will have some naming, some reactions, and some solubility on it more than likely. Okay, so the practice quizzes to look at this week will be 7, 8, 9, and 10. Okay, the practice quizzes for this week. Next week, we'll be doing a lab on chemical reactions and then be starting into the last and do an assignment on reactions as well. So a lab and an assignment on reactions next week. Okay, and then we'll be starting into the last thing in the unit, which is the mole equation. And we'll spend about a week on the mole equation. Okay, so you've still got 3 quizzes left in this unit. Okay, you've got solubility, naming, and reactions this week, all reactions next week, and the mole equation the week after that, and then the Tuesday after that is your unit exam, March the 18th. We may very well be done the unit before that day, and if so, we'll just start biology. No big deal, okay? We'll just start biology before the exam. But I want to make sure we have enough time. I'm not going to move that exam date unless we have to move it further, okay? But I won't move it back. The earliest it will be is the 18th. All right, so you can start looking at that. I always give lots of notice. That way you can start preparing, coming in for help, all that kind of stuff. And it's not like, hey, tomorrow's your unit exam. That's really not fair, okay? So you got lots of notice as to when it is. So that means coming up for you guys, you're going to have a lab report, okay, that's going to be due, all right, because we're going to be doing another lab next week, and you'll have an assignment. Now, I will give you an entire class period to work on that assignment. Lots of people finish it in class, so it shouldn't end up being a ton of homework for you, all right? This week, guys, you need to ask yourself this question. Am I struggling with anything? What's giving me trouble? And then you need to come in and get help. All right, come in and see me for help. If you're still struggling with naming or using the solubility chart or things like that, then you've got to come in and get some help on those things, because if you can't do the naming and the writing of formulas, reactions are going to be impossible. Okay, and I really don't want that to snowball on anybody and then they feel really overwhelmed. So if you're struggling with that, make sure you come in and see me for some help on those things. Okay. What else was I going to say? Felt like there was something else. Must have been super important. Okay, we still have some time here, guys. I didn't intend for you to pack up. I just wanted to make sure I told you all of that stuff before class ended. Okay, there were a couple back here that we didn't do, okay, that I do want you to do, right? And that would be 7 and 8 are the 2 that we didn't do here. Okay, so I want you to do 7 and 8 right now. Give you a few minutes on those, and then we'll go over 2 here. All right, so for number 7, okay, CO is cobalt. Okay, and it is with selenium, so it's cobalt selenide. But does cobalt have more than one possible charge? Okay, so selenide is a -2. Okay, cobalt can be a 2 or a 3. Okay, so in this case, because they're 1 to 1, it must be the cobalt with the 2+ charge. So cobalt 2 selenide, okay, and that is reacting with manganese iodide, but again, manganese also requires Roman numerals. Okay, manganese can be a 2 or a 4, I think. Okay, in this case, it's going to be the 4 because iodine is -1 and there are 4 of them. That means I need 4 positive charges out of 1 manganese. So manganese IV iodide. Okay, and that is going to give us on this side cobalt. Okay, 2, still Roman numeral 2. That won't change. You don't have to figure it out twice. Okay, and once you figure it out on one side, it's going to be the same on the other. So cobalt 2 iodide. Plus manganese 4 selenide. Alright, so that's what that should look like, okay, written out in words. It is a double replacement reaction, okay, because it's ionic compound, everything's ionic, okay, and then we have to balance it. 4 is our biggest number here, so I'm going to put a 2 in front of that, okay, to balance the iodines. Then I'll need to put a 2 in front of this to balance the cobalts. That's going to make my selenium work, and there's 1 manganese on both sides. So that's how it should be balanced. Okay. All right, and then our last one, okay, this stuff here is ammonium chloride. And it is reacting with sulfur. Okay, we don't change its name. That's how it looks when it's by itself. Okay, and that is going to give us ammonium sulfide, okay, and chlorine. Okay, that is a single replacement reaction. And balanced, we need an 8 there, okay, to balance the sulfurs, a 16 here to balance the ammoniums, and an 8 here to balance the chlorines, and then we should be good. Okay, big numbers on that. All right, guys, that's good for today. Hey, little suggestion here. This was the thing I forgot earlier. Okay, we've been playing around quite a bit as teachers with ChatGTP. If you're ever looking for a way to get some extra practice, okay, feel free. Like, just tell it what you want. Right? We made up a couple of worksheets with it, and it was right 85% of the time. Okay, it gave the right solution. So if you're ever looking for, oh man, I used up all the worksheets Coderre made, I don't know if that'll happen or not. But if it does, okay, just go into ChatGTP and make our future machine overlord smarter, okay, by asking it to give you some reaction practice. And it will, and it'll spit them out, and most of the time it'll give you the right answers too. So you can check your work as you go. Totally fine to do that, okay? That's not cheating, that's using it legitimately, okay? What's so funny?
You're saying ChatGTP.
PT, GPT. I always say it, I always do that. It's like I'm dyslexic and I say it wrong. Okay? Yeah. So go ahead and try it. Okay? It can be a source of some extra practice for you if you want it.